Hello, my dear fellow seekers. I hope this video finds you well and excited about our journey into the world of compression rules. I know this topic can seem daunting, but I'm here with you every step of the way. Today, we're embarking on an adventure to understand the design of compression rules. I can already sense your curiosity and eagerness to learn. Let's take a deep breath together and dive in. Remember our last session? We explored how packet headers transform into abstract headers, carrying all those important field values. It's like they're getting dressed up for a special occasion. These abstract headers then go on a journey to the compression entity, where they hope to find their perfect match among a set of rules. Isn't it amazing how our digital world has its own form of matchmaking? Now, you might be wondering, how exactly is a compression rule defined? That's such a great question. I'm thrilled you're asking because it shows you're really engaging with the material. Let's unpack this together, shall we? Here are the magnificent 7 entries. I'll guide you through each one, and please don't hesitate to stop me if anything isn't clear. Your understanding is what matters most to me. Field ID, think of this as the field's name tag, matching the one in the abstract header. It's how they recognize each other like old friends at a reunion. Field length, this is the size of the field, measured in bits. Sometimes the value is hard to determine, so we replace it with a function. Field position, always starting at 1, this value is often used, but sometimes the field is repeated in the header, and this value is incremented. Direction indicator, this tells us in which direction the field likes to move. If it is in both directions, it is said to be bidirectional. Otherwise, we indicate its up or down direction. A field can be repeated with each of the two directions if the values carried are different, or not be present in one direction. These first 4 entries work together beautifully to define a field without any confusion. Isn't it wonderful how these elements come together to create such clarity? Now, let's look at how we compare our rule to the abstract header. Target value, this is what we expect to see in the field, like anticipating a friend's favorite outfit. Matching operator, this guides us in how to make the comparison. It's like having a friendship matchmaker. Compression method, this last entry shows us how to shrink down our header, like learning the best way to pack a suitcase. To make this adventure more accessible, we'll start with a friendly and familiar protocol, IPv6. Our first field is the version field, just like we saw in our abstract header. In the world of OpenShift, we call this field IPv6.var. This little gem is only 4 bits long. There's only one of these in the entire IPv6 header, so we can proudly say its position is 1. Here's something cool: we can spot this field in both directions. That's why we mark it as bidirectional, or B. The traffic class is straightforward, so we'll move on to something more intriguing. Now, picture the flow label, potentially changing its or values regarding the directions. Let's embrace this diversity by creating 2 entries, one for uplink and another for downlink. As we continue our exploration of IPv6 fields, you might find some entries unnecessary. Don't worry, that's perfectly normal when dealing with a relatively simple protocol like IPv6. Let's explore the CoAP rule together. This is where the true magic of our field description method will shine brightest. Are you excited as I am? We'll start with the familiar concepts. The version, type, and token length fields are displayed in much the same way as we used to see in IPv6. Isn't it nice when things are consistent? For the code, we have a little twist. It can have different values depending on the direction. For example, a get in one direction and a 2.05 in the other. Interesting, right? Now here's where it gets a bit tricky. The token length can vary between CoAP messages, and its length is always indicated in the third field. To link these values, she cleverly uses the TKL function instead of value for a fixed length in bits. This means the length is given in bytes by the token length. Pretty smart, wouldn't you say? Options are our next stop, and they're quite flexible. They differ in the uplink and downlink directions. In one direction, we'll have URI path and accept, while in the other, we'll find only the content format. Let's take a closer look at the URI path. The length is variable, which means we're open to any length for this field. It's quite accommodating, isn't it? Then we have a second URI path. Did you notice its position? It's 2 because the field is repeated. And then we have an option accept. That's it for the uplink direction, folks. Remember, the content format can be found in the downlink header. We've defined both the uplink and downlink header formats in a single rule. Here we can see the fields we expect uplink. Are here the ones for downlink messages? It sounds like you've had quite an adventure. A quick nap sounds like a perfect way to recharge. When you're ready to dive back in, exploring the exercises in the Book of Sheik or the MOOC will definitely help solidify your understanding. Enjoy your rest and happy learning. In our next video, we'll take it a step further and explore how we can compare values from the abstract header with the rule. I'm looking forward to continuing this adventure with you.